Hi, everyone. This is Roland with Heimdall Data. Really glad to be able to present to you on the concept of a database proxy and how we can reduce database costs. This is really targeted for an operational perspective as well as a technical. If it's something that you're interested in terms of lowering costs, this is something that you manage in terms of a budget. This is something you can consider. Heimdall Data is an advanced technology partner of AWS. We have competency in data and analytics, and we offer a singular product, and that's a database proxy. Some people call it a SQL traffic manager. Others call it a data access platform or data access layer, like a DAL, as the acronym is often used. And very simply, a database proxy improves SQL read-write performance and reliability without any application changes. So what we're doing is we're offloading developers and operators from having to do additional development work or fix particular SQL behavior. So what we do is we manage the front-end connections intelligently before it hits the database so that your existing database performs at its maximum performance and scale. As I mentioned, the last bullet here, deployment requires no application changes for our database proxy. In this slide here, I show the various database proxies in the marketplace. I'm going to start with AWS, our partner. AWS has an RDS database proxy, and it supports connection pooling, and it's quite a good pooler. It can do very granular pooling. It really was positioned for more for Lambda and serverless technologies, but it can be for other use cases as well. And they support connection pooling for MySQL and Postgres. For those who are deploying Postgres, a popular proxy, it would be PG Bouncer. And they can support connection pooling and read-write split. And read-write split is the definition of being able to separate your queries, writes from writes and reads to the read replicas, so that you can offload a lot of those read queries from the read-write master for better scale out and efficiency. After PG Bouncer, there's also Proxy SQL. And Proxy SQL supports connection pooling, read-write split as well, but it only supports MySQL. So what you'll notice here, the two in the middle, Proxy SQL is a open source technology for Postgres, and PG Bouncer, that is for Postgres, and Proxy SQL is for MySQL, and it is also open source as well. And on the very last is Heimdall Data. Heimdall Data, like the AWS RDS proxy, is proprietary. And what differentiates us is that we do support connection pooling, but our pooling is very granular. It can support pooling at very high connection counts, like the AWS proxy. We also support read-write splitting. What makes us unique is we can also support strong consistency. And these are the various features that separate us from maybe other proxies that can differentiate us. We support query caching and invalidation, Active Directory support, and we are database vendor neutral. So we support all flavors of RDS, that being Postgres, MySQL, SQL Server, MariaDB, or Oracle. Any of those we support. And the way that we support all these proxies is we have two software options. On the right-hand side, we can instantiate as a JDBC driver. So if your application is a JVM, you can insert our JDBC driver in between the application and your current vendor JDBC. So we're not replacing anything. We're sort of shimming in our driver in between your current driver and your application. And when you do that for a JVM-based application, we can support any JDBC-based data source, which includes Oracle. Now, if your application is not a JVM, we can support a proxy that runs as a separate process. in the marketplace, um, our proxy would be hosted on an EC2 instance. But alternatively, you could put our proxy anywhere. It could be on the application server. It could be on your self-hosted database, anywhere you'd like. Okay. And so these are two packaging options, either as a jar file or as a proxy that speaks the wireline protocol of Postgres, MySQL, SQL Server, or any of those derivations. But today we're talking about how to reduce costs. And one of the main ways that you can reduce SQL Server costs is really our query caching. It's all about SQL offloading that traffic from RDS to another store. RDS tends to be one of the most expensive line items of your AWS bill. And so if the strategy here is that if we can offload that SQL and also additionally improve response times and improve database scale, it's basically you get all those three benefits. Okay. So what we do for query caching, this is what I'm going to focus on for the remaining part of this session, is that oftentimes when we tell users that we support query caching, they say, well, how do you differ from Elasticache or Redis? And there's confusion there as to the proxy supporting or selling cache. We don't offer cache. What we're doing is we're providing the caching and invalidation logic, okay, which is the most difficult part. We're saving operational costs in that regard, where you won't spend months, if not year of development and constant maintenance of your caching rules and your policies and setting the TTL and everything. If you put a proxy in front of the database, we're in between the application database, we will intelligently cache those queries to the storage of your choice. And on the left-hand side are a bunch of caches. It could be Hazelcast, it could be Redis, it could be Amazon Elasticache, it could be Pivotal Gemfire. We're all partnered with them, and it could be open source or enterprise versions, doesn't matter. Okay, so we're providing the caching logic to the grid cache of your choice and to the database of your choice. So we give you full freedom of what data store you want to use. In fact, we can actually cache to local memory, to the local heap. As long as you have, you've sized it appropriately, then that can also be a storage, point of storage as well. Okay, we have a host of other features that I mentioned, but we won't get into that for this session. So the flow would be the application would send its query to the database proxy, and if the results are in cache, we will serve it out from cache. So this is, we treat the cache of your choice as a look-aside results cache. So every time we see that exact same query, we will, if it's in cache, we will serve it out from cache. Okay. The application doesn't know that we're caching, and the database does not know that we're caching. This is a transparent solution, such that if you're not happy with a database proxy, you can just rip it out and in minutes, just like you installed it in minutes, and go about your way. So this is a typical deployment of a database proxy. It doesn't have to be Heimdall, but you have your application on your left. Typically goes through an NLB, some type of load balancer, such that it distributes the load and provides proxy high availability. In case one of the proxies goes down, the NLB is able to fail over to the standby or the active secondary proxy. And from the proxy, you hang off a bunch of things. Obviously, the database. Okay, so we're going to be that proxy that captures all the SQL requests and responses. So we provide some really good visibility, and we can execute on some particular rules on that query. And it'll either go to the database or it'll go to, in this case, Amazon Elasticache that we connect to. Okay. And the proxy is the data tier, and it's all being controlled by the central console. And the central console can reside anywhere you like. It provides the analytics, it provides the logging, and it's basically the dashboard which pushes rules and configures the proxies. So the data plane and the control plane are completely separate. Moving on, I wanted to go to a customer success story. The Grammys, or the Recording Academy, had a challenge that their RDS CPU was pegged at 100% during their events. And customers couldn't see live content of who won particular genres because the CPU, the RDS instance was being overwhelmed. So why did they choose Heimdall Data? Well, we were able to offload via caching and read-write split. And they loved the fact that they didn't have to change their application. The benefits were that they were able to reduce their CPU utilization from 100% down to 3% due to caching and read-write split. Their cache hit rate ended up being 90%. If you can imagine, that means that only 10% of the traffic was hitting RDS now. The remaining 90% was being served out from cache. So they were able to reduce their RDS instance size and reduce their costs, their monthly cost, by 50%. Not only did it improve response times, but also reduce costs. And then from an operational perspective, they saved months of development work of not having to implement caching and read-write splitting in the application level. Their application remained untouched. Another example is Zillow. And Zillow needed to improve Aurora scale to support user growth. And they were already maxed out at 15 readers. And even if they wanted to improve the Aurora scale, Aurora can only support 15 readers. And so they did some research on our solution, and they used Amazon Elasticache as a local site results cache to cache SQL results into for Aurora Postgres. And they chose also read-write split to evenly distribute the load and improve scale. So a lot of times, because the endpoints, the RDS endpoints are DNS based, the load is not evenly distributed across the readers. And a lot of the traffic could be biased to going to one reader as opposed to the other. And the other readers don't get utilized very well. And so based on that combination of caching and rewrite split, we were able to improve scale more than 50%. So at 50 readers, they were able to reduce down to like 7 or 8 readers. And they were happy to see those results, especially when it didn't require any application changes. So let's talk about a few use cases. How does caching work? Well, our SQL caching and validation, again, doesn't require any application changes. It's for any grid cache you like, Elasticache, Redis, or Hazelcast. And it uses real-time analysis and statistics on the query frequency and the variability. So if the query results does not change much, and it is a duplicate repetitive query, then it's a very good chance, a good candidate that it should be cached. Okay, so we use statistics on that. Is again, if it's a duplicate query and it's not constantly being updated, the table isn't being updated, then it's a great candidate to be cached, and we cache it. And then we make sure that basically that it's going to provide a performance benefit for you. So it's not only just about caching, but is it going to improve latency? So we're only going to cache if there is a performance benefit. And there's a few modes that you can have in the caching. You can automate it, where you just click the button and say auto cache, and we'll figure out with our learning rules what queries to cache, or you can put in manual rules. And the third one would be taking our recommendations. We have a dashboard that provides recommendations on what you might want to consider caching, and you can take some of those recommendations, or you can take none of them. So you have full control of which queries you want to cache. You can automate it, you can manually configure the rules, or you can do something in the middle. Okay. Now, another way to save costs is read-write split. What you're doing here is, rather than overwhelming the write master, people typically want to scale out by creating read replicas. And what we do is, because we're SQL aware, we talk to the RDS endpoints. We know exactly the status of the instances. So we can do failover, we can do load balancing. We could also monitor the promotion of a reader to a writer. And what makes this very unique is we also support replication lag detection. So if you have a write followed by a quick read, there is a chance that you have consistency issues such that that read will be stale data. We can prevent that because we're a replication lag aware. If we know the read query is within that window, we'll go to the read write master to retrieve that data. So whether it's from cache, the read replica, or the read write master, we can guarantee ACID compliance. And the benefit of read write splitting, like any other feature that we have on the proxy or any proxy, is that to deploy a proxy requires no application changes. So let's talk about a few things that are going on with AWS and Heimdall. Right now, we're offering a promotion for SQL Server. So for those who are SQL Server customers, they may be interested in what we're doing. On the left-hand side, we're going. This is like a typical example where someone's deploying RDS for SQL Server. They're deploying an R5 large. On top of that, they have to pay for a SQL Server license. Okay. And with our enterprise proxy, which in this case is an extra large, R5 extra large, and we're deploying Elasticache, we could deploy, by deploying caching, we can reduce the RDS instance size from 4x to 2x. So we're basically cutting it in half. And cutting it in half means reducing the price or the cost by half. So what you see here is for an 8-core system, RDS system, with Heimdall and Elasticache, would be about 102,000, but we're offering, with our promotion, you would be saving 33%. It's at 81,000. Okay. So you're reducing the number of cores for the RDS, and you're adding on a few more components of the Heimdall proxy and Elasticache, but yet you're saving 33%. Now, it gets even better if you have larger instances or more instances. In this case, a 4x large, 3 instances. Now you have, you're going to cut down 3 instances of 2x large as a result now. And in that situation, it's $222,000 total. But with our promotion, it's going to be about a 44% discount. Okay. And so this offer will be available until the end of June of 2021. So you're really going to be saving about anywhere from 33 to 45% in your RDS costs with this solution, with this query caching solution. What this implies is that your application is read heavy. Again, it doesn't change much. So a lot of times, if the queries are changing a lot, the tables are being updated, by definition, it's not very read heavy, it's not very cache heavy, and therefore this would not be a good candidate for caching to save costs. So we've seen costs reduced greatly through query caching and read-write splitting. Lastly here, we are in the marketplace. So if you'd like a free trial, feel free to download the standard edition. It installs in minutes. You set up IAM roles for your AWS components. And what we'll do is our GUI will auto detect your various AWS components, your RDS, your CloudWatch, your Elasticache, and it all becomes a drop-down menu to configure. It's very simple to configure, and away you go. No application changes and no RDS changes. And with that, we are done.